Alright, here we go. Video 7.4, limiting and excess reactants. What the heck does that mean? Let's talk about it. Alright, first I'm going to throw you the definition. Make sure you're writing this down. Write this down, write this down, write this down. Take notes. Write this down. What is a limiting reactant? Okay, a limiting reactant is going to be the reactant that is totally consumed during the reaction. Alright, it determines the amount of product being made. Now, what in the heck does that mean? Well, let's go back to my example I gave in the first video on this chapter about making grilled cheese sandwiches. We said we wanted to use 2 pieces of bread plus 2 pieces of cheese plus 4 squirts of butter. And I said when we did that, we'd make 1 grilled cheese sandwich. Okay? Now remember, reactants are on the left side of the equation. So when I say limiting reactant, I'm just talking about our reactants over here. Alright? Now, let's say I was at home and I had just bought like 30 packages of cheese. I got a ton of cheese. And I've got like more butter than I know what to do with. But I only have 8 pieces of bread. Okay? Only have 8 pieces of bread. I got more than enough of this, only got 8 pieces of bread. So how many grilled cheese sandwiches can I make? Well, we know that I need 2 pieces of bread to make 1 grilled cheese sandwich. So in our lovely flim chart, if I multiply 8 times 1 divided by 2, we know I can make 4 grilled cheese sandwiches. Alright? Now, what's going to run out? Well, if I use all 8 pieces of bread, how many pieces of bread do I have left? None. I have a ton of cheese and butter maybe left over, and so my limiting reactant would be my bread. I've got lots of these, so that would be limiting how many grilled cheese sandwiches I can make. Okay? Based on the bread, I can only make 4 grilled cheese sandwiches. So this is what this means here with chemical reactions. A limiting reactant is the one that's totally used up, in this case my bread, and it determines how much of the grilled cheese sandwiches I can make, my products. Okay? So 8 pieces of bread only allow me to make 4 grilled cheese sandwiches. If I wanted to make 5, too bad. I ran out of bread. It limited me. The excess reactant is what remains at the end of the chemical reaction after it's stopped. If I come back to my example here, I said I had a whole bunch of cheese and I had a whole bunch of butter. And so my excess here would be the cheese and the butter. Because after I use 8 pieces of bread, I still had plenty of cheese left over and plenty of butter. Those would be excess. It's what's left over. Okay? So when we look at chemical reactions, we put real chemicals together, and what's going to happen is those chemicals aren't perfectly put together in the amounts we need. You might have more of one reactant than the other. Based on the amount of reactant you have and the one that's limiting, it will determine how much of a product you can make. In just 1 second, you are going to see a reaction, alright, where we put vinegar, or where I put vinegar, and baking soda together. Okay, I'm going to put these 2, soda, can spell there, alright? And these 2 things are going to react here. Okay? And they're going to produce 3 different things, but one of the things they're going to produce is carbon dioxide. It's going to fill up the balloon. Alright? And so what this actually produces water and something called sodium bicarbonate. You don't have to write that down. Oops. I'm sorry. It's going to be sodium acetate. That's what I meant to say. Sodium acetate. So it's going to make water, sodium acetate, and carbon dioxide in just a second. You're going to watch the video. And in the video, you're going to notice that either vinegar or baking soda will be a limited reactant. And we're going to base it all on this carbon dioxide that's being produced. So watch the video quickly. Alright guys, we're going to try to help you understand limiting reactants. And to do that, what I have here are 5 different flasks. All of them have 250 milliliters of vinegar, okay? So all of them have 250 milliliters of vinegar, the same amount. 250, 250, 250, 250, 250. Right? Now they all have balloons over top of them, and inside the balloons is baking soda, sodium bicarbonate. Now, if you've never done this before, baking soda and vinegar makes a nice reaction. Right? Each of the balloons have different amounts of baking soda. So for this first balloon we have 6 grams of baking soda. For this second balloon we have 12 grams of baking soda. The third one has 18 grams of baking soda. Right? The fourth one has 24 grams. And the fifth one has 30 grams. Now what I'm going to do is going to turn the balloons over. Right? We're going to let the reaction occur. And when baking soda and vinegar react, they'll produce carbon dioxide, a gas, which will fill up the balloons. All right? Now what we're starting to learn about is limiting and excess reactants. Okay? So the question is, with different amounts of baking soda in it, when I lift up the balloons, which balloon will get bigger? All right? Which balloon will get bigger? I'm going to turn them over. If you'll pause this, give an idea or a guess. All right? And then we'll do the reaction. We'll come back to it and talk about it. So here we go. Alright, it appears that these reactions are done. Maybe a little bit here and there going on. So let's look at them each. So we're going to go to the 8 grams right here. Alright, so here's the 8 gram balloon. And you can see, bring it a little closer, it's kind of small. Now let's compare it to the next one. I'm sorry, that's 6 grams. I apologize, 6 gram balloon. Let's compare it to this one that had 12 grams of baking soda. If we look, alright, the white balloon, oops, and my balloon just blew off. Sorry about that. Alright, the white balloon was bigger than the yellow balloon. That was fun. Okay? Let's look at the next one. So this had 12 grams of baking soda in it. This has 18 grams. We see that the red balloon, or the pink, is a little bit bigger than the white one. Okay? So we had more of a reaction going on. But now when we get over here, alright, if I'm going to compare the 12 grams to the 18 grams, let's look at the balloons. They're about the same size. And let's look at this last one. And this last one had 30 grams, and this one had 24. So, this was 18, 24. Now we have 30 grams compared to 18. Look, the balloons are about the same size. Now what does that mean? Well, in this first balloon, when we did only 6 grams into it, the baking soda all reacted, alright, and got used up completely. So it made the amount of CO2 it could do. Alright, the baking soda got used up, so that means it's limiting. In this second reaction, same thing happened. The baking soda all got reacted and used up. The balloon got bigger because there was more baking soda than the first balloon to react. But the baking soda all still got used up. There's still some vinegar left in here. So once again, the baking soda is a limiting reactant. Let's go to this third balloon. Okay, so this one had 12 grams. This one had 18 grams of baking soda. And once again, the balloon was bigger. All right. But when I compare now the 18 grams to the 24 gram balloon, we see that the balloons are the same size. Now what does that mean? I added more baking soda. Shouldn't it have gotten bigger? Well, what's happening now is my baking soda is no longer the limiting reactant. I don't have enough vinegar in here. So based on the baking soda, this is how big the balloon can get, and now my limiting is now vinegar. So all 3 of these final balloons are the same size because the baking soda no longer gets used up, but all the vinegar gets used up. Since they have the same amount of vinegar, the balloons blew to this same size. Okay? So limiting and excess reactant, it's not just always one or always the other. Okay? When you do baking soda and vinegar together, it doesn't mean baking soda's got to be limiting. It doesn't mean vinegar has to be limiting. It depends on the amount you put in of each. For our first two balloons, okay, actually maybe to these two, the baking soda was the limiting reactant. Got used up, blew the balloons a little bit. We have plenty of vinegar left over. As we got to here, the baking soda started not getting all used up and vinegar was left over. Alright? So this gives you an idea of excess and limiting reactants. Alright, you should have watched the video there. Now, let's just do a problem, a calculation to see how this works. We're going to start small. We're going to talk about moles. Alright? So if I have 5.6 moles of aluminum and it reacts with 3.5, I should say moles. Put that in there. Look at me forgetting my unit. As much as I tell y'all. Sorry about that. 3.5 moles of copper 2 chloride. How many moles of copper will be formed? Which reactant's limiting and which is excess? Now, notice what I've done here. This is different than all the problems you've done to this point. We have two givens. When this happens, we must do two different phlegm charts. Pick one of the givens. It doesn't matter which one you pick first. I'm just going to do the one that's first given. So 0.56 moles of aluminum is this one. I want to know how many moles of copper will be formed. Okay? So this is just a mole-to-mole problem. One step. I want to cancel out moles of aluminum because I don't want this anymore. And I want to go to moles, and this is copper of copper. Alright? I have a mole over mole, so if you remember, we'll find our numbers from the coefficients. For aluminum, it's 2. For copper, it's 3. I'm now going to plug these into my calculator here. And I've got 5.6 times 3 divided by 2. Alright? And I get 8.4 moles of copper. But wait, we're not done. We need to put this other one, alright, into a phlegm chart. We're going to do the exact same thing. So when you're given two givens, what we're going to do is we're going to put them both into our phlegm chart. So we're also given 3.5 moles of copper 2 chloride. Alright? Now, I want to cancel out moles of copper 2 chloride. And once again, I want to know how much copper I will make. So we're going to go to moles of copper. Mole and mole together. Once again, I'm going to use my coefficients. So this time I'm looking at copper 2 chloride, which is right here. It's 3. And I look at the copper. It's also 3. So 3.5 times 3 divided by 3 gives you 3.5 moles of copper. Alright, we have two answers here. And only one of them is correct. So when you do limiting and excess reactants and you're calculating, here's how you figure it out. Put both of your givens in and do two phlegm charts. Alright, they both went to copper because that's what it's asking at. How many moles of copper? Alright, the one that is limiting, the one that's the real amount of copper, is the smallest number that we got here. Okay, so to figure out which of these answers is the correct one, it's the smallest one. Alright, which in this case would be 3.5 moles of copper. This is how much copper will be made. So based on the amount of copper chloride we started with, we can make 3.5 moles of copper. Based on the aluminum, we could make 8.4 moles of copper. But since we're putting both of these together, what happens is as these start to react, you're making copper and making copper. Once you get to 3.5 moles of copper, all of this copper chloride is gone. It's used up. Okay? And so we can never get to this number. So whatever's your smallest, circle it. You can just cross out the bigger one. So now we know how much copper we made. The next question is which reactant is limiting and which is excess. Simple to do. Whatever reactant, remember reactants are on this side, okay? So whatever reactant gave you this smallest number is your limiting. So my limiting reactant in this case, well, what chemical gave us this smallest number? Well, copper chloride gave us the smallest number. So the copper chloride is called the limiting reactant. The excess must be my other reactant, so whatever gave you the biggest number, or the other one, will be your excess reactants. That's the one we had plenty of, and that's aluminum. Okay? I know that was a lot to take in. I'm going to do another one. Alright, this time we're not doing moles, we're doing grams. I got 5.51 grams of aluminum. Reacts with 13.2 grams of copper 2 chloride. Yes, we got to do 2 flowchart charts, and we're going to go to grams of copper. Uh-oh. Yes, that means we're going to do 2 of these really long flowchart charts. So I want to cancel out grams of aluminum and go to moles of aluminum. I want to cancel out moles of aluminum, and we're going to copper, so moles of copper. And when I cancel out moles of copper and go to, oops, not moles, sorry, go to grams of copper. Alright, let's see our numbers. Mole and gram together, my mole will be 1. My grams of aluminum, mole and gram together, we looked at the periodic table. We find aluminum. Aluminum is 27.0 on your periodic table. Mole and mole together, we're going to the coefficients here. 2 for aluminum, 3 for copper. And lastly, moles and grams, my mole is 1. Copper we find on the periodic table, find it with me. And when I look at 63.5, multiply on top, divide on bottom. So I got 5.51 divided by 27 times my 3 divided by my 2 times 63.5, and I get a grand total of 19.4 grams of copper. I gave you 2 given, so you must do this twice. 13.2 grams of copper 2 chloride. I want to cancel out grams of copper 2 chloride. I want to go to moles of copper 2 chloride. Cancel out moles of copper 2 chloride, and I can go to moles of copper. Cancel out moles of copper, and I can go to grams of copper. Alright, here we go. Mole and gram together. My mole is 1. Grams of copper 2 chloride. So I've got 63.5 for copper. Alright, plus 35.5 times 2, because there's 2 chlorines. And I get 134.5 grams. So molar mass in the periodic table. Mole and mole together, my coefficients. Copper 2 chloride is 3. Copper's 3. Mole and gram together, my mole is 1. My grams, my masses from the periodic table for copper is 63.5. So 13.2 divided by 134.5 times 3 divided by 3 times 63.5 is going to give me 6.23, and I ran out of room, grams of copper. Alright, so how much copper did I make? It's just like the last one. Whatever your smallest number you got here is the amount you made. 6.23 is my smallest number. This is the amount of copper I made. That means that I can just mark this one out. So which one's limiting? Whatever gave me my smallest number here is limiting. So I go back to the very beginning, find the chemical. Limiting is my copper 2 chloride. And if that's limiting, then my excess must be my aluminum. So if I put these grams together, what would happen is, once I made this 6.23 grams of copper, there would be no more copper chloride left, so it ran out, it's limiting. And then, alright, my aluminum, alright, would be excess. I would still have some left over, because if it's just based on the aluminum, it could make 19.4. Alright, unfortunately our copper 2 chloride runs out. Alright, that's limiting in excess. One more problem to look at. Actually, what I'm just going to do is this. I'm going to ask one more question here. Save us some time. Alright? How much excess remains? Right? How much excess remains? To add this problem on, guess what? We have one more flim chart to do. What we are going to do on this is figure out, okay, we have aluminum left over. How much of it is left over? And so to figure that out, what we're going to do is we're going to take our limiting and we're going to go to our excess. So we're going to take our limiting amounts and we're going to go to excess. So I'm going to take my 13.2 grams of copper 2 chloride and I'm going to go to grams of aluminum here. So grams of copper 2 chloride, I know that I'm writing small here to save room. We can go to moles of copper 2 chloride and then moles of copper 2 chloride to moles of aluminum, and then from moles of aluminum to grams of aluminum. Alright, mole and gram together, my mole is 1. My mass from copper 2 chloride I already did, so I'm just going to put it in, 134.5. My mole and mole together, coefficients, my coefficient for aluminum is 2. My coefficient of copper 2 chloride is 3. Mole and gram together, my mole is 1. The mass of aluminum is 27.0 from the periodic table. Multiplying top, divide on bottom, we're going to get a number, 13.2 divided by 134.5 times 2 divided by 3 times 27. Alright, this number I get here is 1.77 grams of aluminum. Now listen carefully to what this number is. This number is how much aluminum I used up, meaning 13.2 grams of copper chloride reacted with 1.77 grams of aluminum. My question here asks how much excess remains. To figure out how much remains, you take your original amount of aluminum and you subtract it by how much is used up. This answer that we just got here. So 5.51 minus 1.77, and you get 3.74 grams of aluminum. And that answers this question here, how much excess remains. I know that's a lot, okay? You won't have a ton of these problems, but you will have a few. So make sure you stick with it and work them out. So we'll practice some in class.